Hey guys, today we are working on conservation of momentum practice problems. Okay, so the stuff that we learned about yesterday, now we're applying it to equations or to problems. Okay, so we're going to be talking about elastic, um, inelastic, and recoil. Okay, the different types of momentum that we talked about yesterday. The and I have them separated for you. So normally they won't be separated. You'll have to be able to tell, but you can tell that with the wording. I'll go over that as we go through this. Okay, before we start with elastic, we learned about um, how elastic is I'm going to write sideways here. Okay, the initial momentum of object A plus the initial momentum of object B is equal to the final momentum of object A plus the final momentum of object B. Okay, so this is using the momentum P. All right, but if we use the momentum equation, then it would look like um, mass of object A times the initial velocity of object A plus mass of object B times the initial velocity of object B, and that's equal to mass stays the same times the final acceleration, mass V times final acceleration. Okay, so these are going to be long equations, but in the great scheme of things, it's easier to get what you need by itself so you can solve for what you need. All right, so without further ado, let's do number one. All right, says we have a 10 kilogram sphere moving at 10 meters per second. All right, so 10, did I say kilogram? I honestly don't know what I said, but this is our first object. Okay, we have 10 kilograms and it's moving at a speed. So the initial speed of object A is 10 meters per second. Hits a stationary 8 kilogram sphere. So the second object is 8 kilograms. And don't let this confuse you. If it says stationary, okay, think of like a stationary bike. A treadmill is stationary, okay? It means it's not moving. All right, so if you didn't know what stationary means, if you want to write that down, do it. Okay, stationary means it's not moving. So the initial velocity of object B is 0. After the collision, the 8 kilogram sphere moves off in the positive direction at 4 meters per second. So this gives us a final velocity for object B at 4 meters per second. And it's wanting to know what the velocity of the 10 kilogram sphere is afterwards. So we're looking for the final velocity for A. All right. So this is what we know. This is what we're looking for. And we're going to be using this big O equation. All right, so let's go ahead and rewrite this equation. All right, so bear with me. MA VIA plus MB VIB equals MA VFA plus MB VFB. All right, wrote that gargantuan equation. Okay, we're trying to get the final velocity of object A by itself. Okay, so that's right here. So doing order of operations, first thing I'm gonna do is move over the final stuff for object B to the other side. Okay, so if I do minus mb times the final velocity, because it's being added, then I can do that to this side. Okay, minus mb times the final velocity. All right, so that equals MAVIA plus MB VIB minus MB VFB. Okay, and so that leaves me with, I don't want you getting those mixed in. okay, with mass of A times the final velocity of A. Okay, now to get the final velocity of A by itself, we're going to divide by the mass of A on both sides. Oops, mass of A. Okay, so this is our equation that we're going to be plugging into. All right, looks like I need a little bit more space. Sorry, I'm going to have to be going back and forth. Trying to find a blank space in a spiral. There we go. Okay. So this is the equation that I have. So I'm going to start plugging in these numbers. So the mass of object A is 10 kilograms times 10 meters per second plus 8 kilograms times 0 meters per second minus 8 kilograms times, I'm gonna rewrite that as times instead of closing those parentheses out. Okay, times 4 meters per second. And then divided by the mass of A, which was 10 kilograms. Okay, so before I even plug this all in the calculator, because it's a long equation, I'm going to do some mental math first. If you're comfortable with mental math, do it because it'll make things go faster. All right, 10 times 10 is 100. 8 times 0 is 0, so this is 100 plus 0. 8 times 4 is 32, so minus 32. So essentially on top, we have 100 minus 32, which is 68. And then we're going to divide it by 10. So 68 divided by 10 is 6.8 meters per second. All right, if you don't believe me on that, double check with your calculator, but this is what you should be getting. Okay. Again, I know it's kind of long because it's a lot of different variables, okay? But in the end, the math isn't as challenging as we have done. All right, number 2 says 2 objects collide and bounce off each other, okay? Bounce is the key word here, that it's elastic. Before the collision, object A had a momentum of 10 kilograms meters per second. Object B had a momentum of 12 kilograms meters per second. After the collision, object A has a momentum of 6 kilograms meters per second. What is the momentum of object B after the collision? Okay, so this one is already telling us the momentum. So that means I can use this equation. I don't have to use all these different parts, okay? So object A is initially 10 kilograms times meters per second. Object B initially is 12 kilograms meters per second. After the collision, so the final, object B is, oh, question mark, I skipped a part. And then object A, so PFA, is 6. Okay, so I'm gonna stop this one here, or I can write out the equation, PIA plus PIB is equal to PFA plus PFB. All right, you guys are smart enough and strong enough to be able to figure this out by plugging in this information, okay? And I'm gonna let you guys do number 3 on your own, all right? Number 3 is, let's see. I say you're gonna do it on your own, but yeah. The only thing with number 3 is that it says 2 objects have a total momentum of 400 kilograms meters per second. They collide. object A mass is 5 kilograms, and object B mass is 11 kilograms. After the collision, object B is moving at 15 meters per second. What is the velocity of object A? All right, so something that I didn't write down over here is that this is basically saying that your initial momentum is the same as your final momentum. Okay, so this right here is telling us the initial momentum of 400 kilograms meters per second. All right, and then it's giving us this part afterwards. So I'm going to let you go through and pick out the rest of the variables, but the equation that you're going to be using to solve this will look like this. Okay, I'm being very generous to help you out. All right, what you're going to end up looking for is the final velocity of object A. All right, but you'll be plugging in all this information into this equation. You got it. All right, so hopefully by now you finished 1, 2, and 3, and you're ready to start with the inelastic problems. Okay, again, with this video, I suggest just doing one section at a time and then go back and then continue watching. All right, so with inelastic, the equation that we're going to use is, or remember that inelastic is when two things, instead of colliding and bouncing off each other, they're going to collide and stick together. Okay, so the equation that we're going to use for this is mass of object A times the initial velocity of object A plus the mass of object B times the initial velocity of object B is equal to the combined mass of object A plus object B times the overall final velocity. That's FAB. FAB right there if you can't read it very well. Okay, so again, this is the equation that we're going to be using for the inelastic problems. All right, a 30-kilogram child running at 7 meters per second. So the child will be object A, running at an initial velocity of 7 meters per second, jumps onto a 10-kilogram sled, which is initially at rest. Okay, so that means it's not moving, so it's initially at 0. What will be the velocity of the child and sled immediately after the child jumps on the sled? Doesn't that sound like fun? I wish we had a snow day, and I wish I had a sled, but since we live in Texas, not many people have sleds. That's what cardboard boxes and cookie trays are good for on snow days. Anyways, okay. So this is what we're going to be using. All right. When I use this equation, the mass of the initial, or the mass of the child times the velocity of the child initially, plus the mass of the sled times the initial velocity of the sled is going to equal to the mass of both times the final velocity. Okay, so we're trying to get the final velocity by itself because that's what we're looking for. So if I divide by the combined mass of A plus B on both sides, then I should be able to solve for what I need. Okay, so let's see if I can fit. No, I'm not going to be able to fit them both up here. Okay. So we're going to have 30 times 7 plus 10 times 0, which anything times 0 is what? 0. So I'm going to go ahead and just mark that part out because we don't need it. And then mass of A is 30 plus the mass of B is 10. Okay, so 30 times 7 is 210 plus 0 divided by 30 plus 10, which is 40. So essentially we're doing 210 divided by 40, and that's going to give us a velocity 5.25 meters per second. Okay, and so this is the final velocity of AB, or the final velocity of the child on the sled. Okay, so number 5 says a 12-kilogram train car is moving west at 5 meters per second, collides with another train car at rest with a mass of 10 kilograms and hooks together. What will their speed be after they connect? Okay, so again, anytime it says something connects, it's a good sign that's inelastic. All right, so tells us the initial mass of the first object and the initial speed. And then the second object. And it tells us that it starts off at 0. Okay, and then it's asking for the final speed. Okay, notice that we have the same variables we did in number 4. So use what we did here to finish number 5 on your own. And I'll tell you that number 6, again, is asking for the velocity of the two cars, or the two cars together immediately follow the collision. So you're going to be doing the same thing as 4 and 5. Okay, again, you're smart, you're strong, you got this. Go ahead and finish these elastic problems, or inelastic problems. And when you're done, then try this recoil. Okay, so for recoil, I'm going to use a different equation than what Mr. Luis showed y'all yesterday, but if you understand Mr. Luis's equation and you want to keep using it, by all means, keep using it. Instead, what I'm going to be using is mass of object A times velocity of object A is going to be equal to mass of object B times the velocity of object B, because the momentum of object A is equal to the momentum of object B. Okay, so before I get too far ahead on these, to remind you what recoil is, that's like if I, or the cannon, okay, because that's his first example. When you shoot a cannonball out of a cannon, okay, the cannonball goes this way, the cannon actually jumps back a little bit, okay? And so that's what recoil is when things go in the opposite directions. Now, the cannonball is going to go really far, but a cannonball's mass compared to that of the actual cannon's mass are very different. So that's why when you if the mass of the cannonball increases, then you would assume that the velocity would increase on the mass of the cannon, like it would shoot back even faster the heavier the cannonball is. Okay, so just recoils when these two objects are starting off together and then they're going to go in opposite directions. The speed might be different, but that's because the masses are different, but the momentum overall is the same. All right, so we'll do number 7 together, and then you'll do number 8 on your own. Okay, number 7 says A 15 kilogram cannon shoots a cannonball with a mass of 1 kilogram at a velocity of 120 meters per second. What is the velocity of the cannon? Okay, so we know the mass of the cannon is 15 kilograms. We don't know the velocity of the cannon. That's what it's asking us for. But we do know the mass of the cannonball. And we know the speed or the velocity of the cannonball. Okay, now since these are going opposite directions, we're going to assume that this one is positive, and we're going to assume that this one's negative, because remember that they're going opposite directions. All right, so if we have mass A times velocity A is equal to mass B times velocity B, we're trying to get A by itself, so I'm going to have to divide it by the mass. Okay, so when I plug it in, it's going to be 1 times 120, and then divided by 15. So 1 times 120 is 120, and then divided by 15. When I do that in the calculator, I get 8 meters per second. But again, the cannon and the cannonball are not traveling the same direction. They're traveling opposite directions. So we're actually going to give this a negative because it's traveling the cannonball. So the cannonball is going this way, but the cannon itself is going that way. So that's why I'm going to put a negative right there. Okay. You're going to do number 8 on your own. Again, you're smart, you're strong, you got this. All right, the last part we want you to identify is something is elastic, inelastic, or recoil. Okay. So elastic is when things bounce off of each other. Okay. Inelastic is when things stick together. And so I say bounce, like insinuating that at least one of the objects is moving to begin with, and then they both move and bounce apart. Okay, but with recoil, starts together, then moves apart. Okay, and just to make sure that these aren't confused and that you understand what I'm trying to say, okay, a pool ball collides with another pool ball. If you've ever played pool before, okay, if you've ever played pool before, okay, you have a ball, say you hit this one, okay, and then it hits that ball, well, this ball is going to start taking off. Okay, so they're not sticking together, and one of them is starting off moving. Okay, could kind of say it's a bounce. All right, I'm giving you that. All right, a football player tackles another football player. Okay, so this is two men running. All right, and then they tackle each other and fall down together. Okay. And then a person collides with a medicine ball. Have y'all ever seen somebody holding like one of those big yoga balls? Okay, that's what I'm talking about here. So somebody's holding a big yoga ball and somebody goes and runs into it. You don't stick to the yoga ball. You actually bounce off pretty hard and people actually get hurt doing that. But like, surely, maybe you know what I'm talking about. If you don't, I'm trying to explain it. Okay, but when you hit the medicine ball, you bounce off of it pretty hard. All right. Number 12, a bullet lodges in a wooden block. So I have a wooden block. I shoot the bullet into the block. The bullet is now lodged in the block. All right. Or stuck in the block. All right. Number 13, a shotgun hits the shoulder after being shot. I worded that one poorly, actually. But the main focus should be the shotgun in this. Okay. So you have a shotgun. And if you don't, sorry, I'm a left-handed shooter, so that's why I'm trying to. Okay. So after you shoot the shotgun actually has a really hard kick. So if you don't have the shotgun resting on your shoulder, you're gonna have a very bruised shoulder. So what I'm looking for is like the moment you shoot the shotgun, the pellets go one way, the gun goes the other. That's what I'm talking about. Okay, when the pellets leave and the gun kicks back. All right, what is that called? All right. Um, yeah. So hopefully this helps you out with this worksheet. If you have any questions, ask your teachers. This we're gonna be making this due Monday, so you will have the weekend to do it. But guys, finish this during class or finish it tonight while it's still fresh on your brain. Okay, you're smart, you're strong, you got this.